Hello, and welcome to Backer Breaks It Down. In this episode, we are going to prove two lines are parallel. Okay, let's review some past methods of proving angles to be congruent or supplementary. Okay, so here we are given that angle 1 is supplementary to angle 2, that angle 3 is supplementary to angle 4, that angle 1 is congruent to angle 4, and we want to prove that angles 2 and 3 are congruent. So do you remember why they would be? Okay. And so sup is like a big clue here. Okay. We also notice that in addition to having sup, we have that angle 1 is congruent to angle 4. Okay. And so it just follows that angles 2 and 3 would also be congruent. And this is according to the congruent supplements theorem. Okay. What about this one? We are given that angle 1 is congruent to angle 3. Okay. From my diagram, I know that angles 2 and 3 are vertical angles, which means they are congruent to each other. So why is angle 1 congruent to angle 2? So here's angle 1. Here's angle 2. What do you notice? Yeah, they're both congruent to angle 3. And so when you have angles congruent to the same angle, making them congruent, what is that called? That's right, that's your transitive property. Okay, so one more past proof scenario. Here we are given that angle 1 is congruent to angle 2. From our diagram, we know that angles 2 and 3 form a linear pair, which makes them supplementary to each other. So why is angle 1 supplementary to angle 3? So when it comes to angle 1, up here we said angle 1 was congruent to angle 2. When it comes to angle 3, we said right here that 2 and 3 were supplementary. So what happened here? Yeah, there was a replacement scenario. It's like they replaced angle 2 with angle 1, and they could totally do that since they were congruent, and we call this substitution. So what we saw illustrated in these three mini proofs were three common methods and I don't know, that pop up in our proving lines parallel proofs. So we had substitution, we had transitive property, we had congruent supplements theorem. Okay, so these things are really common to my proofs involving parallel lines. So just to recap, when we prove that two lines are parallel, we use a converse. Okay, so we need to establish one of these 5-angle pair relationships. So we need to show that like corresponding angles are congruent, alternate interior angles are congruent, or alternate exterior angles are congruent. Or we can prove supplementary with our same side interior angles and same side exterior angles. So as soon as we establish one of those relationships, we can prove the two lines are parallel using the proper converse. Okay. And so in number 8 here, we're going to prove the converse of the same side interior angles theorem. Remember, when we prove theorems, we cannot use them in our proof. Okay. So I have 5 converses that I can use to prove two lines are parallel. In this problem, only 4 of them are available to us. Same side interior angles theorem is not available. We have to go around that. We have to use something else. So we know that angle 4 is supplementary to angle 5. We want to prove G and H are parallel to each other. We cannot use same side interior angles to do it. So what are you thinking? Okay. So the only thing that we can absolutely do based on what little we've been given is we can use angles 5 and 6, because we know without a doubt that angle 5 and angle 6 form a linear pair. Because that is something that we are allowed to assume from the diagram. And then where should I immediately go after that? You're right. I can prove they're supplementary. So angle 5 is supplementary to angle 6. And why is that? You are correct again. The linear pair postulate. Okay, so let's step back and see where we're at right now. So we know that angles 4 and 5 are supplementary. We know that angles 5 and 6 are supplementary. What is that? Sup, you say? So what can we do with that? I agree. Okay, so we can totally prove that angle 4 is congruent to angle 6. And why would we want to do that? Because if we can do that, then we can say that like angles 4 and 6, those are alternate interior angles. And if we prove them to be congruent, then the lines are parallel because of this converse here, right? If two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel, okay? And that's like basically what we just did here. So let's finish up this proof. So we just determined that angle 4 is congruent to angle 6 because we had that sup, right? And so that's the congruent supplements theorem. And that means the lines are parallel by the converse of the alternate interior angles theorem. So converse of the alternate interior angles theorem. Beautiful. Let's try another one. So here we are given that line A is parallel to line B. And we are also given that angle 1 is congruent to angle 2. Our goal is to prove that M is parallel to P, okay? So like I know that A and B are parallel. And so that means that there are quite a bit of, like I have those 5 postulates and theorems associated with parallel lines that I could totally use here. My goal is to prove M and P are parallel. So do you see 2 angles that we would use to do that? Yeah, so like if you're thinking like angle 1 and angle 4 can be used to prove M and P are parallel, I would agree. What would we have to prove about these 2? Yeah, we need to prove they are congruent. So this will be like our second to last step. So like basically, once I have proven that 1 and 4 are congruent, then I can prove that M is parallel to P. Okay, now angle 1 is already part of our proof, okay, because it's congruent to angle 2. So how can we bring in angle 4? Yeah, remember A and B are parallel. So like that means like angle 2 and angle 4 would be congruent to each other. Why? Yeah, because they're alternate interior angles. So that would be the alternate interior angles theorem. Okay. So now 4 is part of our proof. So since both angles are now part of our proof, the question is there enough here to say they're congruent? So here's our angle 1, here's our angle 4. Is there enough here to say they are congruent? Yes, you are correct. So we can say that angle 1 is congruent to angle 4, and that is that transitive property. Okay, and we said if we can do this, then we can prove parallel. Which converse is that? What kind of angles are 1 and 4? Yeah, that's right, they're corresponding. So this would be the converse of the, let me move my screen up, corresponding angles postulate. So the key to these proving lines are parallel proofs. Wow. Is thinking about the second to last step. You know, like we said, if we can do this, if we can show angle 1 is congruent to angle 4, then we can prove parallel using the converse of the corresponding angles postulate. So think about that second to last step when you are doing an actual proof of 2 lines are parallel, okay? And then, of course, we always use a converse to prove it, okay? And that's how Backer breaks it down. Good day.